All right. Hopefully y'all can hear me. We're going to go over the second exam. We're going to do version C this time. So, make adjustments if you have version A or B, but essentially same questions, just different order sometimes, different order for some of the answers. So you should be able to see the screen here. So we'll start with exam 2, again, version C, question 1. Let's go into whiteboard. All right, so we have a table, symbol PD 106. We go to our periodic table. We see that that's palladium, which is element number 46. So that tells us that its atomic number is 46. Which means that the number of protons it has to be 46. So that's our first question there. And then our mass number is given in the way that it's written there, PD 106. The mass number is protons plus neutrons. So if I take the mass number minus the protons, I'll get the number of neutrons. So missing pieces from the table, 46 protons, 60 neutrons, or in the order it appears in the table, should have been that one right there. Question 2, cathode ray deflection proved or demonstrated what? So again, with the cathode ray, we had the cathode tube, generated whatever those cathode rays happened to be, weren't necessarily sure at the time, applied a negative and positive attractive force to those, saw that they were always attracted towards the positive electrode and deflected away from the negative. So that proved that electrons have a negative charge. What's the average atomic mass of an element that has two naturally occurring isotopes? So we have only two isotopes. So what we have to do is figure out the weighted average of these. So we're going to take the mass of our one isotope, 120.9038. We're going to multiply that by its abundance as a decimal. So we're not actually given the abundance of that one. However, we are given the abundance of the other isotope. And since the two of them together are going to have to add up to 100, we can see that the abundance of the other one should be 57.4%. So we're going to multiply that by its mass. And then we're going to add that to the weighted average, or the weighted mass for the second isotope, 122.9042 times its abundance, which we were given the 42.6%. So when we do this, we get that value there, and this value here. When I add them together, I get that, and then, well, technically this. And if we go out 4 digits after the decimal, that should be our average atomic mass right there. Select the which compound is ionic. So we have C3H8N2O4 MgCO3 and P4 O10. So remember, for ionic compounds, we want a metal and a non-metal, or we want to see a metal and a polyatomic ion, or a polyatomic ion and a non-metal. In this case, these are all non-metals, so that's out. Both of these are non-metals, so that's out. Both of those are non-metals, so that's out. Here we have a metal, and we have a polyatomic ion, carbonate. So that was our ionic compound out of those. Which the following is not true about isotopes. So isotopes are same element, but with differing number of neutrons. So if we had, carbon 12, carbon 13, and carbon 14, the thing that makes them all carbon is they all have to have 6 protons. And then what we'd see about each of these that changes is this has 6 neutrons, this has 7 neutrons, and this has 8 neutrons. So what's not true? They all have the same number of protons. Nope, that's true. They all have the same atomic number. Nope, that's true. These would all be element 6 in the periodic table. They're all the same element. That's true as isotopes as well. They're all still carbon. So the only one that isn't true is that they have the same number of neutrons. Nope, isotopes have differing numbers of neutrons. Choose the most correct formula for titanium 4 phosphate. So titanium is a transition metal, but that 4 part right there tells us the charge on that. So that tells us that we're dealing with titanium with a 4+ charge. Phosphate is a very specific polyatomic anion, it's PO4 with a 3- charge. So what I have to do is figure out how many titaniums do I need with how many phosphates so that I end up with a charge neutral species. So in other words, if that's +4 and this is -3, what number do I have to put in front of those to get me to 0? What's the smallest number that they'll both go into? That should be 12. So to do that, I would need 3 titaniums and 4 phosphates. Or I can cross these values here, and what I should get is titanium 3, and then to indicate that the phosphates were only, or we're increasing every part of the phosphate, it's that whole chunk together, we would put the 4 out, this in parentheses, and the 4 outside of that. So that should be the correct formula for titanium 4 phosphate. In which set do all elements tend to form anions in binary compounds? So again, an anion, negatively charged ion. So in this case, it was the fluoride, chloride, bromide, or fluorine, chlorine, and bromide are all going to form anions, negatively charged fluoride, chloride, and bromide. The others were either always cations or a mix, where some might be cations, some might be anions. But the only one that was all anions were the fluorine, chlorine, bromine. Give the most correct name for HClO2. All right, so this, you'll notice, leads with that hydrogen. And again, typically if they lead with a hydrogen, that means it's an acidic hydrogen. So we have an acid. So taking out that H+, what leaves us with a ClO2-. So we have an acid with an oxygen-containing polyatomic ion. So that's what we call an oxyacid. To name that, we figure out what's the name of the polyatomic ion. Well, ClO3- is chlorate. And if you remember, if I subtract an oxygen from that, it goes from having that ATE ending to that ITE ending. And if I have an acid where the polyatomic ion has the ITE ending, it goes from that to OUS. So this is chlorous acid. If we had chlorate, ClO3, that would lose the ATE and get an ick. That would be chloric acid. But because we have chlorite, it's chlorous acid. All right, what's the mass of 6.022 times 10 to the negative 2 formula units of sodium chloride? Well, we have to figure out how many moles that is. So to do that, we would divide the number of formula units here by Avogadro's number. Some of you may have noticed this is just 1/10 of that. So we have 0.1 moles. And then we would just find out the molar mass of sodium chloride. So add the mass of sodium from the periodic table, which is about 23, to the mass of chlorine, or chloride, which is 35.45. And you should get a molar mass of around 58.45 grams. Multiply that by the number of moles you have, 0.1, and you should have 5.845 grams for this particular problem. Other ones, I can't remember, might have been a different value for some versions, but the way you're going to set it up again is going to be identical. Identify the smallest subatomic particle. So we know that the neutron is pretty large. The proton is also pretty large, just slightly smaller. Neutrons like 1.008 AMU, and the proton's like 1.007 AMU. But the electron is noticeably smaller. It's something like 0.0055 AMU, or might even have another zero in there. So out of those, the smallest subatomic particle was the electron. Which elements are considered noble gases? So noble gases, column 18, or main group 8A, last column on the periodic table. So you got helium, neon, argon, was it krypton next, xenon, etc. So out of those, you had helium, neon, argon as your choices. The others there were some halogens, some alkali metals. Give the correct name for the following compound, SO3. Well, now I have a binary compound of only non-metals, which tells me it is not ionic, but this is a covalent compound. And when we name covalent compounds, we name the first one, or it keeps its name just as it is. This would be sulfur. There's only one. So we have the prefix mono, but we don't use it for the first element. So instead of calling it monosulfur, we would just call it sulfur. And then the oxygen loses its gen ending and becomes oxide. And then we would put because there's three, the tri prefix in front of that. So it should be sulfur trioxide, or trioxide, sorry. Which element is defined by the following characteristics? We have 11 protons. We have 12 neutrons, and we have 11 electrons. So that right there, if you look at the periodic table, should be sodium, really based on that. And it wouldn't have any charge because the number of electrons matches the number of protons. It's the correct formula for iron 2 nitrate octahydrate. So we've got iron 2, so that tells us it has a 2+ charge. We have nitrate, and we have octahydrate, so we're going to have some number of hydrates or waters. So right here, we have to figure out how many of each of these do we need. We're going to need a single iron to balance out the single negative charge, or the two single negative charges, sorry, for the nitrate. And then octa is 8, so we'd have 8 H2Os right there. How many oxygen atoms are contained in 132 milligrams of sodium sulfate? And the molar mass of this is 126.05 grams per mole. So we want to know oxygen. So I'm going to divide 132 milligrams by 1,000 to get into grams. And then I'm going to take that 0.132 grams and divide it by the molar mass. and we get 0.001047 moles. And then for that, for every sodium sulfite or sulfite that we have 3 moles of oxygen. So I want to multiply that by 3. That gives me 0.00314161 moles of oxygen. And the last thing we want to know is number of atoms. So then we're going to use Avogadro's number to go from moles to atoms. And that should have given us 1.89 times 10 to the 21 atoms. What's the mass of 1 mole of C3H7OH? So we're going to find our individual masses. Carbon is 12.01 from the periodic table, and there's 3 of those. There's actually 8 hydrogens here. So we'd have 8 times the average atomic mass of a hydrogen. And then we have a single oxygen. So we take all these, multiply them, add them, and we should get 60.094. And this is, so a single one would be AMU. This is for a mole, so we're looking for the molar mass. So now it would be that many grams in 1 mole. Which the following is defined by having 17 protons, 18 neutrons, and 18 electrons. Well, the protons determine our atomic number. What element is this? 17 tells us it's chlorine. Protons and neutrons together give us our atomic mass. That should be 35. And now we'll notice, we'll look at the electrons here. We do have 1 more electron than we do a proton. So in this case, this should have a negative charge. So that should have been the correct symbol for this element right here, defined by the parameters they gave us. Right, for this one, we have 135.7 grams of this C3H7NH2, and we want to know how many moles is that. So you may have a different value in terms of your mass, depending on what version you have. But again, either way, we're going to set it up. We need to divide by the molar mass of that C3H7NH2. So similar to what we did in an earlier problem, I'm going to figure out, the individual mass of carbon, hydrogen, nitrogen, multiply them by the number of those that we have. So 3 carbons times 12 gives me 36. The 9 hydrogens times 1 is 9. That's 36 plus 9 is 45. The nitrogen is 14. So this is going to have a molar mass around 59, or I think what I got here is 59.102 grams. So I'm going to divide the amount I have, 135.7 grams, by the molar mass, 59.102. And in this case, I get 2.296 moles. And out of sig figs and your answer choices for version C anyway, that's what you'd have. Again, you may have had a different mass on your version. Instead of 135.7, you might have had some other value. Still divide by the molar mass and get number of moles at the end. 19, a cation is defined as. So a cation, again, positively charged ion. So to do that, we are playing always with the electrons, not with the protons, because if we play with the protons, we change what the element is. So to do that, it has to lose an electron and gain positive charge. So cation is defined as an atom that has least electrons and forms a positive charge. Lastly, the mass of an element is equal to, so we're looking for how do we find that mass number? And that's always the two heaviest subatomic particles, protons plus neutrons. All right. So that goes through all the exam for version C. Make adjustments for version A or B. If you have any questions, please feel free to ask. If you think there was an error in your grading, stop by my office. We'll pull your Scantron. We'll double check it, make sure everything's correct. Maybe you bubbled something in a little too lightly. We can fix that. But yeah, hopefully you find this helpful, and I'll see you in class.